So, we finally managed to get the interaction stream running. Let's see what kind of data we can get from it. This is the familiar pattern to get data out of the interaction frame. First, we open the interaction frame in a using statement so that we can dispose of it as soon as possible. If the interaction frame is not null, we copy the data into the prepared user infos array. This is an array of user info objects. This object contains all the interaction data related to the specific user. It has two public properties: skeleton tracking ID, which is the ID of the user corresponding to the user in the skeleton stream. If this equals 0, it means that the user info object does not contain a valid user. The next property is called handpointers, and it is a read-only collection of interaction handpointer objects. This collection contains the hands of the specified user, and since Kinect is optimized for humans and not aliens, it probably won't have more than 2 items at a time. Let's go further. Our next subject is the interaction handpointer class. This class represents one hand of the user. I have created a small WPF application to examine how it works and display all properties of the interaction handpointer class while I'm moving my hands around. I will use the Kinect Studio so that you can see what I'm doing while the numbers are updating. Let's look at all the properties one by one. On the top right, you can see the raw depth output from the Kinect. Below it is the cool 3D viewer from Kinect Studio, showing a side view of the scene. On the left, my nifty little application shows all the properties for the 2 interaction handpointer objects for my hands. The numbers are pretty fuzzy now because my hands are on my knees and the Kinect cannot see them. As soon as I raise my right hand, its numbers become much more stable. The row X, row Y, and row Z positions are where the hand is in the physical interaction zone. For the row Z coordinate, 0 point is a little bit in front of me. All 3 row coordinates are between 0 and 1 for the interaction region, but the actual numbers can be outside of this range. For example, now I'm outside of the interaction region and the row X number for my right hand is 1.2. For the X coordinate, the numbers increase from left to right, and for the Y coordinate, the numbers increase from top to bottom. The non-row X and Y coordinates are interaction-adjusted coordinates. The hand type property indicates whether the hands that belong to the interaction handpointer is the left hand, right hand, or neither. Neither does sound a bit funny, but the interaction hand type enumeration still has this option. The isTracks property indicates whether the hand is being tracked by the skeleton engine, although I cannot make it false even if I hide my hand. The isActive property indicates whether this hand is active. When it is true, the hand is a candidate to be labeled as a primary hand for the user. The isInteractive property, on the other hand, indicates that the hand is in the physical interaction zone. Next is the isPrimary for user property. Each user has one primary hand when it comes to Kinect interactions, although you can ignore this when you are using the InteractionStream directly. As we saw in Module 2, the primary hand is the one which the user has raised first. If I'm raising my other hand now, this hand is not considered primary as long as the first hand is still raised. Let's talk about gripping now. Hand event type is another enumeration showing the grip event that has happened to the hand in the current frame. It is very important to note that this property is set to grip or grip release for one frame only, when the grip state of the hand changes. For all other frames, the value of this property will be none. To make tracking the current grip state of the hand easier, I'm also displaying the last hand event type value. It is not part of the interaction hand pointer class, but I will show you the code later on how to keep track of the user's hand state. Gripping is a binary gesture, which means that you either have your hands open or closed. Pressing is a different kind of animal. This is different from what we are used to with the mouse or touch. The mouse button is either pressed or not. The touch screen is either touched or not. However, to facilitate the user feedback that we saw earlier, in addition to the isPressed Boolean property, we also have a floating point press extent value. This value is proportional to how far along the press gesture the user's hand is. This is how the hand cursor gets filled and gets attracted to the center of the button, and indicates that the button is about to be pressed. When the press extent is 1 or higher, the isPressed property becomes true.